Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on IPv6. Let's start our part 7.
Now, as I mentioned, there are multiple ways for us to configure the tunnel. So it's either manual or automatic. Now, on the manual, we also have the manual way as well as using the GRE tunnel. Alright, so here we are going to look into the manual tunnel, not the GRE tunnel. So here, alright, we have a manual tunnel. Now the topology is exactly just like the earlier one. I have PC1 want to connect to PC2 purely running on IPv6 over the tunnel. Okay, but this is a manual tunnel. And for the manual, we have to specify the tunnel source and the tunnel destination. And the type of the tunnel is the IP tunnel. Okay, and this is being set up on the edge of the router between R1 and R2. And the protocol that we use here is protocol 41. Now this is the common one. Assuming that you are the user and you want to connect to another site is purely IPv6. Now rather than you connect through the R1 and R2 on your own, we can actually configure or we can subscribe a tunnel broker. The tunnel broker basically is your service provider that configure the tunnel for you. And that normally they are using a protocol 41. Now another type of manual tunnel is using the GRE tunnel or generic routing encapsulation tunnel. Alright, so this is one type of manual tunnel. Okay, and this tunnel endpoint must configure manually again. But the difference over here, if you compare this one and the earlier one, you can see that here I have IPv4 header and IPv6 header. But you refer back to here, I have IPv4 header and I insert a GRE header and only IPv6. Now the technology used is very similar as per earlier one. So instead of the protocol 41, they are running on GRE. And the benefit over here is using GRE, you can tunnel not only IPv4, you can also put in IPv6 into GRE, OSI, as well as MPLS as well. So this is a good thing on the GRE. And GRE is pretty common and most of the routers do support GRE tunnel. Now as you can see that just now I mentioned that for us to create a tunnel, we have our manual and automatic. And manual, as I mentioned, that we have the manual using protocol 41 as well as using GRE. Now for the auto, we have our IPv4 compatible IPv6 tunnel. And what is that? Okay, now firstly, you notice that this is an automatic tunnel. Okay, and it's used IPv4 compatible. You notice that the first 96 is 0, all 0, followed by IPv4. Alright, as you can see from here on the left hand side and the right hand side here, this is just purely IPv4 addresses, but it's using a /96. And on the IPv4 facing, I'm using pure IPv4 which is routable. Now the bad thing over here is each host must have a valid IP address. Okay, and this is a ::. So the first 96 bit is all 0. Now this is something that we seldom see nowadays. Now the more common one is this one, which is the 6 to 4 tunnel automatic. Now this is an automatic tunnel and you can set up between routers to routers, host to host, router to host, and host to host as well. So we have router to router, host to router, router to host, and host to host. Okay. Now this time, rather than using a 96 of all 0, we are using 2002 as our address, and with the /48. Now for this part here, you can see that the address are quite defined properly in a structure rather than the 0. Now first one here, we have our FP. FP stands for format prefix. The format prefix over here is 20 and 2. Okay, now here we have the TLA. TLA stands for top level aggregator. Alright, so in combination, if we do a FP plus TLA, and we have the 16-bit. Now IPv4 is 32-bit. So when we add 16 plus 32, that will give us 48-bit. Alright, so here 2002, which is consists of this FP, format prefix, and TLA, top level aggregator, that will give us 2002, and with the IPv4 32-bit. Now the SLA is stand for site level address. So here we have 16-bit. Okay, now what you can see from here on this automatic tunnel is that rather than we are using all the 0 as in 96-bit of a 0, okay, which is : 96, here we have a more structured address, 2002 : IPv4, which is your existing IPv4 address, and followed by your SLA or site local address. Now you can see that the format is similar except that the address are different. So you can see that the format here is IPv4, IPv6 header, and IPv6 data. Now the SLA, site level aggregator, is used for a very specific use. So let's look into what's the purpose of a SLA. Now similar to the earlier topology, you notice that I still have the 624, but right now I have two of this site. Okay, so you can see that this router have three interfaces. So let's say that this is a gig 00, gig 01, and gig 02. Now these two interfaces are different subnet altogether. So you notice that this part here, the 16-bit, okay, the 16-bit over here, all right, they are different. The first part over here is the same. Do you notice that? Okay, and the site level aggregator in this case is 1, and in this case is 2. The SLA is 2. So when one edge device can connect to multiple 622 networks, so this is the first one and the second one, we need to use this SLA. So 624 network are differentiated by the SLA ID. So now you have the reason why you have the 2002, that's fixed the IP address as well as the SLA. Okay. Now continue to different scenario, but we are still in a 624 tunnel. Now you notice that this topology are slightly different. The addressing scheme on this network is just purely IPv6, which means that they are not following the address convention using 2002, so it may be using 2001 something something. Okay, so under this instance, the router on this edge need to configure as a relay. So IPv6 here is going to connect through the relay before it's actually go into the tunnel, because this is still an IPv4 tunnel before it go into the 624. And if let's say the 624 want to go back, again it's actually terminated in 624 relay before map back into IPv6 or to the 624 network. So just remember that for this instance where you have a network that doesn't support the 624 addressing, then you have to configure the relay method. Now another way for automatic tunnel is called isotype tunnel. Alright, so isotype stands for intra site automatic tunnel addressing protocol. Alright, so that is the isotype. Now isotype can be set up from host to router. Okay, so we have a host to router, router to host, the other way around, or host to host, as you can see from here. Now if you look into the isotype tunnel, they do have a very specific address. There is a dedicated address. Now you notice that on the first 16-bit, you can see that these are the 0 except for the U and the G here. The U here represent whether this one is a global address or whether it's a private address. If it's a private address, it's a 0. If it's a global, then it's a 1. The G here, if it's a unicast, is a 0. If it's a multicast, it's a 1. So if let's say we are going to divide them into the hex number, so this is 0, this is 0, so this is 0. So if let's say this is a unicast, okay, so this will be G will be 0. U in this case, as I mentioned, if let's say this is a private, is as a 0. If it's a global, is as 1. So assuming that this is a global address, it becomes 0200. But if it's a private, then it will be 0. Okay. Now next we have the second 16-bit over here. You can see that this one is 4 bit. Sorry. So here, let me do again. 1, 2, 3, 4. 4 bit here. 4 bit here. 4 bit here. Now if you turn this bit into the hexadecimal, so this is 0101, that will be 5. This is 1110, that will be E. This is 01 will be F. This is 1110 will be E. You notice that there will be 5 EFE, 5 EFE. And this one will be purely IPv4. Now this is a dedicated address on ISATAP. Now let's look into this topology. Now assuming that on the left hand side here I have a PC with the IP address of 3::8. And I have a PC2 and a PC3. Now both the PC2 and the PC3, they have to be a dual stack. Okay, dual stack. Now as you can see from here, they have IPv4 and the IPv6. Okay. Now let's look into the PC2. The PC2 IPv4 is 10.1.2.5. Now when we use the ISATAP, they are going to use a link local FE80 followed by the dedicated address. Now remember I told you that if this is a private, then you have all the 0 in front, so that will be double colon. That is the 5E FE over here, followed by the IPv4. Now if you look into the IPv4, A is 10.1.2.5, which is the 10.1.2.5 of IPv4. So now you can see that this is self-generated if you are using the tunnel protocol as ISATAP. So I have IPv4 and IPv6 over here. And if let's say they want to communicate, they can actually communicate via IPv4 if let's say they are using here IPv6 or even for ISATAP tunnel. And between the PC2 to the ISATAP router, they actually tunnel through the ISATAP tunnel over here. So same for the routers here. You can see that I have the IPv4 that representing over here. That's my ISATAP dedicated address, and this will be my IPv6 address. And from here, they're able to communicate. So again, this is an automatic tunnel, and this is quite a popular way for us to set up a tunnel because of this flexibility. Last but not least, if let's say in future, most of our network is already in IPv6, but some of it we are still stuck in IPv4. In this case, we call legacy. Now we have to tunnel the IPv4 into IPv6. So IPv4 is the internal data, IPv6 is the header. Okay, so IPv4 over IPv6 tunnel allow IPv4 packet to be transmitted over the IPv6, but we don't have to worry about this. But you just need to aware that this will come in future. But at this moment, we will be more interested on how we can run the IPv6 over IPv4 and not IPv4 over IPv6. Now it's time for us to look into the configuration. So here I have a few labs that we are going to do. We are going to look into configuring RipNG that on the earlier slide, as well as I already showed you a simple configuration on RipNG, OSPF, RSIS, and BGP. I think that these two, which is important on how to configure manual tunnel and the GRE tunnel.
Thanks for watching. Please do not forget to subscribe to our channel.